Astronomers expected a routine flyby. Instead, 3I Atlas flashed an intense, focused beam aimed not into deep space, but straight toward Mars. Spectra went weird. Brightness spiked and crashed. Colors flipped like a cosmic mood ring. And then the light aligned, deliberate, precise, unsettling. Is this a freak of physics, or something planned? Why does its path skim the planet's plane with needlepoint accuracy? And what happens if Earth is next in line? Today, we pull apart the data, the claims, and the wild possibilities without jumping to conclusions. Because what's coming up may be stranger than the headline. When comets don't behave. For most astronomers, comets are predictable guests. They follow long, graceful arcs around the sun, warming up as they approach, shedding gas and dust in a steady rhythm, and glowing with a brightness that can be charted months or even years in advance. They are the dirty snowballs of space, beautiful, but ordinary. That's why 3I Atlas has thrown the rulebook out the window. From the moment it was spotted, it began doing things no comet is supposed to do, forcing experts to question whether they were even looking at a comet at all. The first anomaly came in its brightness. Normally, comets brighten gradually as their icy surfaces heat and vent gas. With 3I Atlas, the change was abrupt and erratic. One night, telescopes captured it at a faint 18th magnitude, making it nearly invisible against the dark sky. Next, it exploded to 12th magnitude, bright enough for mid-range observatories to track. Then, just as suddenly, it faded again. These wild swings repeated over and over, sometimes in less than 24 hours, leaving astronomers scratching their heads. Expensive instruments were recalibrated, tested, and retested, but the culprit was not broken gear. It was the comet itself, behaving like a cosmic strobe light. That wasn't the only surprise. With most comets, the glow originates from a diffuse cloud, known as the coma, that surrounds the nucleus as ices vaporize. But early observations of 3I Atlas suggested its light was coming directly from the surface. This wasn't a fuzzy halo, it was a pinpoint glow, as if the object itself was generating light. For scientists accustomed to comets behaving like passive reflectors of sunlight, this was like stumbling on a snowball that somehow makes its own fire. Now came the color shift, many comets changing color gradually as the solar heat induced the sublimation of different molecules that fluoresce. This process is well documented. Reds, blues, and greens appear at expected distances from the sun. But with 3I Atlas, impatience set in. The shift from red shades to green was accomplished so much quicker than physics allowed, well before entering regions where carbon compounds normally would trigger that type of change. It was as if the object had tantalizingly skipped ahead in the playbook, broadcasting signals in hues not yet able to be called on. For scientists, each of these anomalies raised troubling questions. Were the brightness irregularities associated with some exotic chemistry, or is it something deeper and possibly an internal energy release? Was the surface glow a signature of some exotic dust, or did it hint at a reflective or engineered surface? And what of the color change? Was that the signature of something we've never catalogued, or is it suggestive of a process outside our models of cometary behavior? As the nights continued to pass until that date and the numbers appeared to pile on, it became ever clearer that 3I Atlas was not going to comply with neat, predictable-looking equations. Its behavior seemed more like that of the rebellious teenager of the solar system, acting as if it had been given a free pass not to follow every rule that was laid down in 4 billion years of comet observations. Every spike, every fade, every unnatural jerk took astronomers that much closer to the realization that they were either being privileged witnesses to a new class of object or, really, something masquerading as one. And yet, that was only the warm-up act. 4 brightness tantrums and color tricks, the next feature violated a law of physics that any student learns in Astronomy 101: the direction of the tail of a comet. What 3I Atlas did with its tail wasn't just unusual, it was impossible. The forward beam paradox. Every comet has one rule carved into stone: its tail always points away from the sun's solar wind and radiation pressure push dust and ionized gas outward, like a cosmic windsock showing the flow of stellar particles. It doesn't matter how the comet spins, how big it is, or what it's made of, physics guarantees the tail streams in the same direction. But 3I Atlas, it seems, didn't read the manual. Images captured by telescopes showed something nobody expected: a narrow, forward-pointing structure. Instead of trailing behind, this beam of light extended toward the sun itself, as though the object were shining a spotlight straight into the glare. Astronomers scrambled to explain it. Was it an antitail, a known but rare phenomenon where geometry creates the illusion of a forward spike? Normally, antitails appear faint and fleeting, visible only under specific alignments when Earth, the comet, and the sun line up just right. But this was different. The structure was bright, long, and most unsettling of all stable. 4 days, the beam held its form, reaching 10 times farther than any antitail ever recorded. Its intensity rivaled the normal tail itself. Instead of a diffuse glow, it looked concentrated, almost focused, like a flashlight cutting through space. Natural processes scatter light in all directions. Nothing in physics should allow a comet to produce a directional beam that holds its shape over vast distances. Yet there it was, etched into the data. Scientists tried their best to salvage the explanation, applying dust mechanics. Perhaps unusually large fragments had shed and drifted ahead, strangely scattering sunlight. However, that was still something of a stretch. The solar wind should have pushed those chunks behind. For them to remain forward, they should have withstood those forces that dominate comet dynamics measured and corroborated innumerable times over by the entire solar system. The odds were getting really thin. Others claimed electromagnetic effects. Could charged particles have been shipped around some invisible magnetic field, producing the illusion of a forward stream? The trouble was this: no comet has yet shown such behavior at this scale, plus magnetic fields strong enough to affect such behavior should be detected. The math also stood firm against them. Thus, then, commenced the whispered conversations. If the beam was not a command tail, was it a signal? Was the tightly focused forward light somehow intentional, for example, by way of directed energy, communication, or propulsion? Most chose not to articulate it, but the question was almost tangible. An antitail that points toward the sun is like having water run uphill, or fire that is cool. It breaks just too many laws that the explanations start to tiptoe into the realm of science fiction. The forward beam was not just counterintuitive, it became a choice: accept that nature has hidden a trick we may still not have figured out, or entertain the unsettling idea that perhaps something or someone was guiding this light. And if the beam raised eyebrows, the chemistry raised alarm. Because what 3I Atlas is made of doesn't fit into any known category of comet or any natural object at all. Chemistry that shouldn't mix. When astronomers trained spectroscopes on 3I Atlas, they expected the usual dirty snowball recipe: mostly water ice, dust, carbon monoxide, and the occasional organic trace. What they found instead looked like someone had taken the periodic table, shuffled it, and dealt the cards at random. The readings suggested a bizarre blend: about 87% carbon dioxide, 9% carbon monoxide, and a meager 4% water. That's not just unusual, it's upside down. In every other comet studied, water dominates. It's the driver of outgassing, the source of a glowing coma, the foundation of their icy bodies. Strip away the water, and the physics of comet activity collapses. Yet here was 3I Atlas, behaving wildly, while carrying almost none of the ingredients comets are supposed to run on. Then came the real kicker: nickel without iron. In natural cosmic environments, nickel and iron are inseparable twins. They form together in stars, fuse in supernovae, and land together in meteorites. To find nickel in isolation is like finding salt without chlorine or oxygen without hydrogen. It doesn't happen in nature. But 3I Atlas didn't seem to care. Its spectral fingerprint revealed nickel standing alone, with little to no iron to accompany it. Planetary scientists considered this a chemical crime scene. How could these materials coexist in such concentrations? If formed in an entirely different planetary nursery, the proportions must arrange themselves according to common rules of element formation. To explain 3I Atlas, you would have to conjure an environment where carbon dioxide was as common as sand, where nickel condensed alone, and where water abundant everywhere else was scarce. Either this object then comes from a totally different system, or else these materials were somehow manufactured or separated. The mixing of weird ingredients did not stop there. Trace compositions were the fuel to the fire, the exotic molecular lines not matching common cometary volatiles, and hints of unstable structures that should have already fallen apart long ago, drifting through interstellar space toward our solar system. Each measurement forced the screws of mystery tighter. If this were indeed a comet, it was a comet that was not made right. Skepticism encouraged caution, they said. The information was scanty, gathered in tough conditions for observation under conditions that muffled noise. Misinterpretation could give rise to results very strange. Still, this pattern was consistent enough across instruments to make such a view difficult. There was even evidence of solidity within margins of error so softened that percentages could be considered extreme for defense. The two options that remain were either 3I Atlas being a natural body from an alien system with such a chemistry our templates, or it is nevertheless something else designed or altered object to contain materials we would not have expected. Neither answer is tenable. One forces us to rethink how planetary systems can form, the other suggests intelligence had a hand in shaping what we're watching. For now, it has the spell of a riddle in the spectrum, but if chemistry raised the question of origin, its path through space advanced an even stranger question: intent. A path that feels planned. Interstellar visitors usually wander in on chaotic paths, swooping into the solar system at steep angles before disappearing back into the void. They don't care where the planets are. They don't hug the orbital plane. They certainly don't time their closest approaches for convenient observation. But 3I Atlas seems different, as though someone plotted its route on a star chart instead of letting chance decide. From the start, astronomers noticed its trajectory was unusually flat. Rather than cutting across the solar system at an odd tilt, it threaded almost perfectly along the same plane where Earth, Mars, and the other planets orbit. That's like throwing a dart from light years away and hitting a line thinner than a piece of paper. The probability of such precision occurring by accident is vanishingly small. For most interstellar comets, the odds say random. With 3I Atlas, the odds whisper guided.